Okay, so the last thing for this section is what's called Descartes' rule of signs. And this was developed way long before we had graphing calculators, probably by René Descartes. And what he figured out was if we have a polynomial p of x and it has real coefficients, no complex, we're not doing that, written in standard order, descending order, and a non-zero constant term, which is the thing that always trips me up, okay? Then we can figure out the maximum number of positive real roots by looking at the number of sign changes in p of x. So that would be the maximum number, but it could be fewer than that by multiples of 2. Okay, for negative real roots, we're looking at the number of sign changes in p of negative x, or being less than that by a multiple of 2, by a positive real number. Okay, so our first one up here, we have a little bit of a tricky one because there's no constant term, right? The constant term is 0. Oops, constant term is 0. Oh no. So what we're going to do first is we're going to factor out an x. So we'll have 5x to the 5th minus 3x squared plus x minus 1. Now we are going to count the sign changes for the number of positive roots. So we've got positive to negative, we've got negative to positive, we've got positive to negative. So we have 3 sign changes. So we have 3 positive roots, or we're just going to count down by 2's, or 1. And we can't count down by another 2 because we'll go below 0. Doesn't work. Okay. Now, what about g of negative x? Now, we're not going to worry about the x term here because we know that that has a root of 0, right? We'll go ahead and write that 0 root. We have 1. And now we're looking for negative roots. And so we've got to say, okay, we're going to look at this 5x to the 5th minus 3x squared plus x minus 1. We're going to plug in negative x because the x out front, all it's going to do is flip all of the signs, which the number of sign changes is still going to be the same. All right, so if I plug in a negative and I raise it to a 5th power or an odd power, it's going to change the sign. So 5 times negative x to the 5th is negative 5x to the 5th. An even power is not going to change sign, right? Because negative 1 squared is 1. Then we have plus x, so that'll be plus a negative x and minus 1. And so how many sign changes do we have? None. No sign changes. So that means no negative roots. So what that means is that we have either 4 or 2 real roots, right, of which either 3 or 1 are positive, and 2 or 4 complex roots. Okay, so if you can find 3 real roots, you know you got to find 1 more. Okay? So that's kind of the idea here. It's just helping you to narrow down what you're looking for. Once you find 4 real roots, you are done. You're going to find those last roots are going to be complex. Okay, we have 1 more. This time we have a 12th order polynomial. We do have a non-constant, non-zero constant. So with no 0 roots, we're looking at positive roots first. And we're going to say, okay, from positive 5 to negative 7, that's one change. Negative 7 to positive 3, there's 1. 3 to 1 to 1, no more. So there's only 2, or less than that by a multiple of 2, so it could be 2 or 0. Now we're going to say, okay, what about h of negative t? So remember, even powers are not going to change sign. Odd powers will. So we have minus t plus 1. That's the only thing that's going to change here, right? So when we count our sign changes, positive 5 to negative 7, there's 1. Negative 7 to 3, there's another. 3 to negative 1, that's another. Negative 1 to 1, we got another one. So our negative roots, we can have 4, that's the sum of the sign changes, or 2, or 0. So what does that tell us? The maximum number of real roots we have is 6. So max number of real roots is 6, which means we have a minimum that is, if we have 6 real roots, we're going to have 6 complex roots. Our minimum number of real roots is 0, 0 plus 0, right? And that would mean that we have 12 complex roots. And you might also have 4 or 2, but you know, that at least helps you narrow it down some. If you find 6 real roots, you're done with the real roots. Now you got to find the complex. Okay, and that is just a little bit about Descartes' rule of signs. And that's the end of the chapter.